Direct current stimulation, or TDCS, is a non-invasive brain stimulation technique used to promote brain plasticity. It does this by applying weak electrical currents to specific parts of the brain to facilitate or inhibit spontaneous neuronal excitability. A nodal stimulation works to excite neuronal activity while cathodal inhibits. One of the growing applications of TDCS is treating people with autism spectrum disorder. Autism is estimated to affect 1 in 70 Australians and influences the way a person feels, thinks, interacts, and experiences their environment. People with autism are shown to have altered growth patterns in their brains, and particularly in the frontal cortex and amygdala. In the frontal cortex, an increased number of neurons has been especially found in the dorsolateral prefrontal cortex. This has guided the majority of research to apply a nodal stimulation to the left dorsolateral prefrontal cortex. The dorsolateral prefrontal cortex is responsible for and associated with a wide range of executive and cognitive functions. These include emotion regulation, working memory, selective attention, planning, and abstract reasoning. A study by Amatachaya et al. 2014 found that after using TDCS on this region, cortical activity increased, whilst the targeted symptoms decreased, which demonstrates a possible mechanism for the effects of TDCS. This elevated cortical activity is presumed to cause an increase in synaptic connectivity. This same idea that increased cortical activity will increase synaptic connectivity has been applied to other brain regions to attempt to target different symptoms of autism. Studies by Wilson et al. 2018 and Lockhart et al. 2021 found significant improvements to social communications and interactions for people with autism when using TDCS on the temporoparietal junction. Lockhart et al. 2021 found it increased that brain region's connectivity. This increase combats the disrupted connectivity theory of autism as the likely mechanism for why TDCS reduces autism symptoms. This theory states that deficiencies in how the brain coordinates and synchronizes activity amongst various brain regions accounts for symptoms of autism. The effects of TDCS on autism are found to be positive in reducing symptoms. However, there is generally a large variability to different studies, methods, and results. A study by Hadush et al. 2020 had 50 children with autism receive simultaneous anodal TDCS over the left and right prefrontal and motor areas of their brains. Half were split into the control group and received sham TDCS, which is just a fake TDCS. The treatment group went through 10 20-minute sessions, 5 per week. The children took the ATEC, or Autism Treatment Evaluation Checklist, before and after the study. The ATEC has 4 categories of behavioural, health and physical conditions / health status, language and communication, sociability, and sensory / cognitive awareness. And whilst this is administered by non-professionals like a carer, it still holds validity as it generally significantly correlates with the CARS evaluation, which is a more accurate tool administered by a professional. The treatment group had a significant decrease in sociability and health status scores, which in a practical sense meant an improvement to them. No follow-up studies were completed, which hinders the study's validity. A randomized double-blind crossover study by Amatachaya et al. 2014 used either a nodal or sham TDCS on the left dorsolateral prefrontal cortex for 20 minutes for 5 consecutive days on 20 participants with autism. This was then repeated for the half that used sham TDCS. They found significant decreases in symptoms using 3 separate autism evaluations. Interestingly, they found a reduction in almost all the ATEC categories except for language. The researchers completed a similar study in 2015 with another 20 participants, but with only one 20-minute TDCS session to reveal significant improvements in the social and health status components of the ATEC. This, however, was not followed up to see how long the improvements lasted. Due to the variability in methods and results as highlighted by those 3 studies, it is hard to determine the most efficient way to use TDCS to reduce autism symptoms. As shown by the Garcia-Gonzalez et al. 2021's meta-analysis, when measuring with the ATEC, studies will show a reduction in at least one component of the model. Amatachaya et al. 2014 reported that 3 components of the ATEC were reduced under their stimulation of the left dorsolateral prefrontal cortex, which might suggest this is the most beneficial area for TDCS, as studies like Hadush et al. 2020, which used simultaneous TDCS, only reduced two components. This variability has led to a gap in existing knowledge and a question for future research to determine which brain region utilizes TDCS best. Several studies like Amatachaya et al. 2014 study in particular will suggest it is the left dorsolateral prefrontal cortex. Once this is further studied, determining how long TDCS needs to be applied for and if the follow-up sessions are required will be easier. Another important direction for future research is to be able to generalize reliable results reported through having more randomized controlled trials that use standardized and comparable evaluations like the ATEC and the CARS. This can lead to more confidence in TDCS, which would result in the clinical use of it for autism. Whilst in Australia, TDCS was given the green light for clinical settings in 2017, depression seemed to be the only disorder with sufficient evidence for its use. Once these directions are studied, the picture on where to use TDCS and the appropriate duration when treating people with autism will be much clearer, resulting in the potential for thousands of Australians with autism to receive TDCS in clinical settings and reduce their symptoms.